Hey guys, super excited to be here for the first time. And if you've ever wondered how to do these really nice particle simulations that look very wispy and very magical, well, today is your lucky day because I'm going to show you how to do that. And one of the things that I want to show you guys primarily is how to use the velocities from your volume simulations or your smoke simulations to drive your particle simulations. And then we're also going to dive in a little bit into rendering at the end. So I'm not one much for intros, so let's just jump right into it. So first we're going to go ahead and drop a geometry node. Let's go ahead and call this pop sim. Why not? Go inside. By the way, to go in and out of your nodes, you could press U to go up a node or enter once you have one selected to go into a node. To kind of drive this point, I want to create a random geometry. Let's say we'll do like a ring of smoke. So to do that, we could do a tube. And let's go ahead and drop a poly extrude here. And let's make it a little thick. Let's make it a little bit, about this much. I want to go ahead and export this side group to come out of this node. And from there, we're going to use that in a blast. Okay. And I want to basically isolate that side group that we extruded. Afterwards, I'm going to go ahead and do a delete. I'm not going to spend too much time on the geometry making, but I promise I'll get to the fun part. So we're going to drop a delete, uncheck off this enable. We're going to delete by normals. Okay. Enable. And I wanted to basically delete based off of my y axis and my normal. So I'm going to put 1 here and bring this down to 0. Okay. So you're not seeing anything now, but once I start kind of playing with this, you'll see that it brings back these geometry. This is not the one that we want. We actually want the one that was deleted. So we're going to bring that up and here we have it. So now you're probably asking, why didn't we just do a blast node to delete just based on these here? And the answer is simple. If I had done this, right, delete non-selected, and let's say, for example, I wanted to change the amount of rows and columns that I had. Once I do that, it starts messing up my geometry. I don't want that. So I want to do things a little bit more procedural. That's why in creating this poly extrude, you can output a group. That group is the side group. It's going to be this group that I got extruded here. So whenever I want to go in here and let's say I want to start, sorry, not there. I want to start adding more resolution to my geometry. It's going to be outputting the primitives onto the group that I wanted to. So now that we have that settled, we continue on. We're going to do a match size. Match size is a wonderful node that brings everything down to your world center. So we want to go ahead and keep that there. I also do feel like this is a tad bit too thick. Let's bring this in a little bit here. And then we're going to do a scatter. And then on here, we want to go ahead and click off relax iterations. We're going to randomize the positions of all our points. And let's give ourselves a little bit more resolution. Let's do 25,000. Now, at this point, you want to be careful. You need to know your PC specs and you want to know how much your computer can handle. But in this case, I'm going to stick with 25,000. I think it's a good number. Another thing that I want to do in my viewport is I want to change this background to dark. And I also want to look at my points, not as points, but rather as pixels. I believe it's a little bit cleaner when you look at it this way. I also want to go ahead and just hide my my grid. Now we're going to go ahead and start creating our pyro network. So from here, I want to drop in attribute adjust float. Now this node is a wonderful node that helps you create attributes that are more specific floats, right? So a float is anything that's like a 0.1 or a 1.5. It's basically a number, point something, and it's only one, right? As you can see here, as soon as I drop my attribute adjust float, it automatically creates a P scale for me on the point class. So here in my geometry spreadsheet, you see that I have a P scale of 0.0. I can, let's say, do random. And now I have a random amounts of P scale. So you see everything here is normalized between 0 and 1. Min value is 0, max value is 1. I could do, let's say, for example, 5 and 0.1. And you're going to see that everything in here is going to be between 0.1 and 5. We don't want to adjust our P scale. We want to go ahead and adjust our density, right? Because we want to go ahead and have this go into our pyro network later on. I basically did already a little bit of experimentation to see what settings I liked. So I'm going to go ahead and just put that on here. A noise, I think, would do fine. And if you want to go ahead and visualize what your attributes are looking like, you can press on here on this little button, and you'll basically see what you're affecting. I believe 0.15 here, 1 there would be a nice value. We can also go ahead and remap it here, right? When you remap it, it's almost like you're upping the contrast, right? So we want to have a nice little fall off here, but we can always play around with it. We can do something, a little bit like this. Why not, right? Let's bring this down and maybe something like this. Get an interesting shape in there, And then our element size, we could bring this up to 0.3, right? We can get some nice little variations on there. Very nice. Next thing I want to do is basically just copy this and paste it, because now I want to do this for my temperature. So basically, why are we creating temperature? It's because we need density and we need temperature to have our smoke simulation look kind of nice. You can also move this around if you like. You could do an offsite here so you can, make it look different. We can go ahead and click on here so we could see what we're affecting. I'm going to leave it back at what we had it. By the way, if you want to move a parameter back to what it was, right? So let's say I had it at 5. You can just control middle mouse button over the parameter that you want to affect, and it'll revert it back to its default settings. So afterwards, we're going to do a point velocity, right? We want to randomize our velocity a little bit. Let's go ahead and just stop visualizing our points here. Now I want to visualize my velocity, which we can click on here to look at velocity. Let's do a curl noise. So we're going to click on here. We already see that we're getting in some randomization to our velocity. We're not going to go too crazy into it. You can layer your velocities. And if you decide to layer your velocity, so like let's say, for example, we have another one coming in. We want to make sure that when we go to the initialization, you want to go ahead and press keep incoming, because you want your velocity to come into this node. You want to manipulate it here. In this case, I'm okay with just the 1. So let's say, for example, I'll use this at 0.5 and a swirl size of 0.71. Again, I know these numbers because I've already played with them. If you guys want to go ahead and play with these parameters, you guys can get something pretty cool. By all means, yeah. Another interesting thing that you guys are going to be seeing me do quite often is organizing my nodes. And to organize your nodes, a nice little shortcut here is if you select all your nodes, hold A on your keyboard, click and drag from where you want it to align to, it's going to organize your nodes, right? So like, let's say, for example, I have something like this, right? I'm putting things down and I just go on here, A, drag it down, and I have a nice little node network here. I want to drop a volume rasterized attributes node. So the reason I'm dropping this is because as of right now, these attributes that I created, so density, temperature, velocity, they're just regular point attributes. You even see it here. I want to turn these into attributes that Houdini can read and basically use the data that's coming into it and affect a pyro sim later on. The way that it is right now, these are just point attributes. We want to go ahead and create volumes. To do that, we can drop a volume rasterized attribute, which I have here. Now, it's gone. And don't panic. It's because we need to tell Houdini, all right, these attributes that I have, I want them to be volumes. As of right now, it's not getting anything. So I wanted to say, I want my density, right? I want my temperature, and I want my velocity. Now, you're probably looking at this monstrosity like, this is not at all what I ordered. And trust me, we're getting there. What we need to affect here is our voxel size and our particle scale. So once again, I already played with these parameters to get something looking nice. So I'm going to go ahead and adjust these parameters. Keep in mind, when you adjust your voxel size, once again, it depends on your computer. You could get a long wait time for Houdini to cook. So just be mindful of that. What I would do first is adjust my particle scale to 0.02, right? So now I have it down to roughly the shape that I had, right? You can almost even see the variations of density here. And my voxel size, I want to bring down to 0.03, right? If you do your particle scale first and then your voxel size, you should have a quicker cooking time. Now, I don't want to see all my attributes, okay? Right now with my node, it's telling me that it's bringing in everything with this asterisk. I don't want everything. I only want my density. I want to visualize my density. So we're going to go ahead and drop that in here. And just like that, we're visualizing our density. It doesn't mean that I'm not importing or creating these temperature and velocity as well. It just means that I'm visualizing it. That's it. If you middle mouse button on here, you'll see that I have 3 VDB volumes. I have a density, a temperature, and a velocity. Let's go ahead and organize this once again. We're going to drop a null. And in this null, we're going to go ahead and call this out smoke source. Why not? Then we're going to drop a dop network. We're going to call this smoke sim. Whenever I do a dop network and I do a smoke sim, I like to label them. To label it, you could press C on your keyboard and it's going to bring up this color palette and you can click and drag the color that you want. So now I know whenever I have a big complex node tree, whenever I see a specific color, I know that that color means something. So then we're going to go ahead and dive inside. From here, we're going to drop a pyro solver sparse, a volume source, and oops, put that in the wrong category, sourcing. And we're going to drop a smoke object sparse. Now, be very careful when you're dropping your smoke object. If you drop a regular smoke object and put it into your pyro solver sparse, you're going to get an error because your pyro solver sparse is expecting a smoke object sparse, okay? So just be mindful of that. We're going to go ahead and find that on here. And we're going to put this there. Very good. And now we have something, okay? Now, in our volume source, we're going to tell Houdini, this is the object that we want. So in our volume source, we're going to go ahead and tell Houdini what it is that we're going to create a smoke simulation out of, right? So we're going to go ahead and we could do SOP or we could do first context geometry. In this case, we can do SOP. We're going to pick which one we want. So we're going to pick object, popsim, out smoke source, accept. And now we're going to go ahead and click off enlarge fields that contain sources, initialize source smoke. And just like that, we have our density that came in, our temperature, and our velocity. If you see here, the source volume in the target field, basically, this is Houdini's way of saying, this is the name of the attribute that exists on the SOP level. This attribute will be manipulating this attribute, which is a DOP specific name, right? So, for example, I could have named my density something else. But if I named it something else, I need to make sure that under source volume, I'm referencing that attribute. In this case, on the SOP level, we named them accordingly, right? We named it, we named it density, we named it temperature, and we have our volume, our velocity. Houdini automatically names your velocities V. And if you see here, V is manipulating vel, right? So that's how we're creating our velocity. Vel is a DOP network way of saying velocity. And another neat little thing here is that we can always, our source scale, we can adjust how much of that attribute we want to affect our smoke simulation. So on your free time, if you want to play around with these 3 parameters, by all means, you might end up getting some very interesting results. But let's keep going. Now, if I press play, you're going to see absolutely nothing. And now you're probably thinking to yourself, great, I did something wrong. In that case, you didn't. But the problem is that under your voxel size, it's too big, right? It needs to be finer in order to catch some of that data. So if we bring this down to, let's say, for example, we bring this down to 0.05. And once again, this is completely dependent on your machine. If you want to go at it little by little until you see something up here, by all means, I think that's a smart move. In this case, I'm going to go ahead and put 0.05. And you're going to see that it increased the resolution of my simulation. So when I press play, I'm seeing something now. Now, remember, we're going to be using the velocity of this smoke simulation to drive particles. In this case, I don't want to focus too much on the resolution of the density. What I really care more about is my velocity. So if you want to play around with PyroSim nodes, by all means, there's a bunch of very interesting ones. You have gas turbulence, you have gas advect, you have gas forces, gas wind. So you'll get some very interesting things. In this case, we're just going to stick with our solver, and we're going to go to our shape, and we're just going to click off everything. We're not going to move anything around. We're just going to leave it as is. So once we press play, we're going to be getting a little bit of breakup in our smoke simulation. Another thing that I want to do is under my simulation, I don't want this to go up too high. So I'm going to go ahead and bring this down to 0.5, for example. So that should keep it from going up too high, too fast. Okay. Another thing that you could do if you want to control that is adjust your temperature. So you could bring down your temperature to, let's say, 0.1, and you're going to see that it's not going to be moving up too high or too fast. This is looking fairly interesting. So let's go ahead and let's leave it at that. So let's leave it at 0.5. What does that look like? That looks interesting. We'll leave it at that. If you want to go ahead and export this, and if you want to adjust your resolution, your voxel size, you can, by all means. So now that we're done here, what we have to do in order to bring in our simulation from DOP world into SOP world, we're going to have to create a DOP import field. Now, the difference between DOP import and DOP import fields is that field is for volumes. So we're going to go ahead and drop DOP import fields. We're going to click and drag what it's asking us for here. So our DOP network is going to be our smoke sim. It's asking us for our DOP node. Our DOP node is our smoke object sparse. So I'm just going to copy the name, and then we're going to bring it into here, into our DOP node. And then under presets, I'm going to pick smoke. So now it automatically brings in my density, my velocity, my rest, my temperature, my CD. Once again, I'm only really interested in my velocity. I'm going to keep my density and my temperature, but really this is the field that I want to see. So we're going to go ahead and optimize our data here a little bit. We don't want rest. We don't want CD. We'll just keep temperature, velocity, and density. Another thing that we could do to further optimize our smoke simulation is drop a pyro post process. So one thing that you notice here is that when we bring in a smoke simulation from DOP world into SOP world, it turns our volumes into Houdini volumes. So we have our density, we have vel X, vel Y, vel Z, and temperature. I want to optimize this a little bit more by turning them all into VDBs, and I want to combine my velocities. So the pyro post process node actually has these buttons that do that for you, right? So if I convert to VDB, combine volumes, you'll see now that all of my Houdini volumes are now VDBs, and it actually combined my velocities into a vector. You can also convert this to a 16-bit float that further optimizes your data. In this case, the simulation is fairly small, so it's not really going to make much of a difference, but just so you know, if you're working with bigger simulations, this is something that you could also play with. Now, we're going to create a cache node, if I can spell it correctly. Great. And we're going to go ahead and drop this here. And before we do that, we want to go ahead and save this. Once you create your file directory, you can go ahead and save your file there. In this case, we're going to go ahead and name this, pop underscore bell underscore YT for YouTube. You know, why not? Tutorial underscore bookdev underscore version 001. Cool. So, I'm sorry, 2. I already have a 1. So we're going to go ahead and press accept. And we're going to go ahead and start adjusting our file cache parameters. For one, I don't want this to be too long. Just for the sake of this example, we're going to make this 4 seconds. So we're going to make this 96 frames. I don't like it when the file cache node automatically does this for you. I like to work a little bit more explicitly. So when you see here on geometry file, if you middle mouse button, it tells you what that $hip is. In this case, it's giving you the file directory to where this particular file is being saved. So we want to keep this. I don't like hip name. Hip name is the name of your actual Houdini file. So we're going to name this, for example, the name of our node, which is $OS. So we're going to copy this. And we're going to put it into a folder that says the name of this cache. So that's why I'm putting this into this file structure, /geo / the name of the node that we're saving, / now the name of the node, the $f.bgo.sc. Perfect. So we're going to name our node, and we're going to call this smoke cache YT version 1. So we're going to click on there and we're going to drop a null. And on this null, we're going to say out smoke sim. Why not? So we're going to go ahead and save to disk. We have the little drive logo here, so we know that we're reading from the disk. Once I press play, you're going to see that this is playing back very quickly. Perfect, very good. So now that we have our smoke simulation and we have our velocity, we want to go ahead and start working on our pop network. Now, I promise the pop sim is going to be a lot simpler than this. So let's go ahead and drop a null. And we're going to say out up sim. Very good. I just want to organize this a little bit. I'm a little bit of a neat freak here. Let's go ahead and get cool. And now we're going to drop a another DOP network. So we're going to drop DOP network. We're going to call this pop sim. Once again, we're going to color this. I like to color my pop sims pink because why not? And we're going to dive inside. We're going to drop a pop source. Same thing as our pyro sim, pop source, pop solver, the brains, and a pop object. Very good. And now we're going to go ahead and actually have this reversed. Put this in here, put this in there, and we have a pop solver. So now that we have our pop sim, so I want to go to my pop source now, and I want to bring in my points. So we did it the other way where I showed you that you click here, but I want to show you guys another way where if you do period slash, right? So that means that we're getting out of this node into this, into DOPS. We're going to do another period slash because now we want to get into our SOP level, right? And we want to go ahead and find the node that we're looking for, which is out pop sim, which I should really rename that. Let's say pop source. And if you notice, it actually renamed it accordingly. So I didn't have to change that. Very procedural, very nice. And I don't want this to scatter onto my surface. I want to use all points. I want to use all the points that already come into the DOP network. I also don't want to use guide because I just want to see my points here. Another thing I'm noticing here is I still have my velocities. I'm going to turn that off. And this is where the magic happens. This is the node that I want to show you guys. The pop add vect by volumes. Great. So we're going to go ahead and plug this in. It's looking for a field name called vel. Remember, vel is the DOP way of saying velocity. So in saying vel, we're doing the right thing. This is what we want. Great. So now we need to say, where is this velocity coming from? So we're going to do the same thing. We're going to do the period slash. We're going to go out smoke sim, right? Because that's where I know that my velocity lives. We're going to change this from update force to update velocity, right? I'm going to change my advection method from single step to trace midpoint. And let's see what comes out of it. There it is. We have our points being advected by our smoke. Very, very cool. Now, if you noticed, I will let it load up here really quick. If you notice on the areas where there is no longer any smoke simulation or any smoke velocity data, the particles, they don't know what to do. So they just kind of stay there. One thing that we could do here is just lower down our birth to, let's say, for example, to 1 and our variance to 0.2. Life variance means that it's going to do 0.2 from the number either up or down from this life expectancy. So now the life of my particles is going to be anywhere from 0.8 to 1.2. Let's go ahead and go back. Let's press play. And now we're getting something nice. We're getting something cool. Now I want to go ahead and add a pop rint. Let's go ahead and just randomize this a little bit more. I'm going to put this here. And let's lower down our air resistance to 0.1, amplitude, let's say 2, and swirl size of 0.25. Okay, just add a little bit of breakup. Another thing that I want to do here is I want to jitter my birth time and interpolate source. So that way I can randomize the birth positioning of my particles. So here we can do negative, right? We're going to do back and match topology. see what we have so far. One of the reasons I'm doing that is because I want to avoid stepping. I want to avoid this kind of like banding effect that you could get sometimes. And once you play with those settings, you should get something fairly smooth. Another thing I want to do to kind of randomize my velocities is instead of using inherited velocity, we can add to inherited velocities, right? So now we're adding a variance of 1, 1, 1 on my X, Y, Z for each of my velocities. So once I do that, you're going to see it's a little bit more chaotic, right? We're not going to get any banding of any sorts, but it's just another thing that we could do, another tool in our tool belt to combat that. Another thing that you can do is up your substeps, but keep in mind upping your substeps could result in slower processing times. So tricks like this can help you avoid any stepping, and you can optimize your memory, your computer. So let's go ahead and organize this. Let's add our gravity force. Cool. And now we're going to do the same thing that we did the last time, which is add a dop import. So now we're not importing volumes anymore. Now we're importing points, right? So we want to use a regular dop import. So we're going to just go ahead and drop this here. Cool. And then in our dop network, we're going to go ahead and drop in this. Same thing as last time. We're going to copy our pop objects, go in here, objects, pop sim, pop object 1. Perfect. Very good. And now I want to add here something interesting, something that we can use to randomize our colors for our particles. In order to do that, we could drop a particle fluid surface. On this particle fluid surface, I don't want surface polygon soup. I want particles. And under visualize, we can turn this to velocity. And I don't want these colors. I think these colors look nice and all. I mean, at the end of the day, you could change these to whatever colors you like. But for the time being, I'm going to change this to something a little bit more sinister, something a little bit more evil. So let's do black body. Yeah, this is already giving us some interesting results, but let's change this up. Let's get a little bit more creative, right? Let's do like a green. And here we could do the lime green. And make this a little bit brighter, right? Then on here, you can make this a little bit darker. And then under our visualize, you actually bring this up just a tad bit more, right? We can play with these settings so we can get a little bit more of this end into our sim, right? We could do 5, we could do 7, we could do 8. Oh, that's 89. We don't want that. Let's leave it at 8, right? I want to get some of that in there. Let's actually bring this down just a tad more, maybe around there. Let's add a little bit more fall off. Yeah, I think that's looking really nice. Yeah, look at that. It's pretty cool. I want to do another attribute adjust floats. And the reason I want to do an attribute adjust floats is because I want to randomize my P scale. And now you're probably asking, why are we going to randomize our P scale? Well, you're going to see now when we start rendering this. So I want to go ahead and add here a random. And let's say, just for the time being, let's do 0.1 and 0.5, right? No thought process. I'm just throwing in random numbers in there. And we're going to do another null here. And we're going to do out to locks, right? So if you want to cache this, by all means, you can cache this. This is fairly lightweight simulation, so I'm not going to cache this just for the time being, but you can and should cache this for your records. So now we're going to go from here to rendering. Another little thing I want to show you guys is here is if I press Control 1, it's going to create like a little bookmark. So whenever I press 1, it's going to take me to this node tree, right? So if I press U to go back up and I press 1, it takes me back to exactly the point where I press Control 1. Now it's going to be very helpful because we're going to go into Solaris. Just go into our stage context. And you can see that we're in Solaris now. We're going to start rendering. This is where we make our pretty pictures. And from here, we're going to start building our render tree. So we could drop a SOP import. And what do we want to import? We got to go and click on here. Our pop out to lots. This is what we wanted. and we're bringing it in here. Same thing as before. I want to look at this on a dark background where my particles are pixels. Don't want to see my grid. So now we have everything exactly how we have it before. We're getting a little error here. To get rid of that, we can just press merge SOP into an existing active layer. Basically what that was saying was that there was no save path for this SOP node. Once we press merge SOP into existing active layer, it should get rid of that. Now, our import path prefix, as you see here in our geometry spreadsheet, it's SOP import. But we want to be a little bit more organized. Let's say this is our environment. Let's put this lowercase, and then we'll do $OS. Okay. So now you can see here in our geometry spreadsheet, I created a transform primitive where there is a SOP import underneath, right? But I don't want to call this SOP import. Let's say this is our pop sim. And now if you look inside our pop sim, we have our points. So we have our pop sim, and then we have our points that are coming in here. So now that we're here, I want to go ahead and press Control-2. So I just set a bookmark to come here, and I'm going to do a material library. I want to start creating my materials. And in Solaris, we do that by creating a material library. Now, once again, I want to be organized. So basically, when I go in here, let's say, for example, and I do a Karma material builder, you see on my geometry spreadsheet, I have a materials primitive that exists outside of my environment. And I don't want that. I want it to exist inside of my PopSim. So in order to do that, under my material path prefix, I'm going to go ahead and copy parameter. Right here, I'm going to click paste relative reference. And let's call this MTL. Because why not, right? We want to be different. So then now you see here when my middle mouse button, it says environment, PopSim, MTL. Now, once again, I want to make this a little bit more procedural. So I can do a primitive node, right? And I'm going to create a primitive. You can see here, once I drop that, a primitive 1 just dropped here. And we want to call this environments. So now I know every time I drop something in here or name this, it's going to name the root primitive of all my nodes moving forward accordingly. So I'm going to go ahead and copy parameter. Go in here, paste relative reference, and now I have it. Environment, PopSim. Perfect. And once I go in here, same thing, environment, PopSim. So now under our material library, we're going to name our Karma material, let's say PopSim, right? We're going to dive inside, and I want to use the color data that's already on my particles to drive both my base color and my emission. Now, this is where things get a little bit tricky, right? So let's say, for example, I were to assign this material to these points. And to do that, we'll do an assign material node. And my primitive that I want to affect is here. And the material that I want is my PopSim. Once I look at this through Karma XPU, one, you're going to notice a couple of things. You're going to notice our particles are absolutely massive. And another thing you're going to notice is that the colors on my points are the colors of my base material right here, right? It's white. So if I were to turn this to red, it's going to turn this to red. So that's not what I want. I want it to be the colors that are already on my particles. Now, how do we do that? If you notice, we here next to our points, we have data that's already coming in to our Solaris. And the one that we want to look for is display color. Display color is the Houdini, is a Solaris equivalent of CD, right? It's display color. And how do we reference that data into our material library? Well, if you notice, this is a primvar. A primvar is Solaris's way of creating an attribute that is not native to Solaris. So like, let's say, for example, if we were to create a custom attribute, it's going to be read into Solaris as a primvar. Things like widths and velocities, these are attributes that are native to Solaris. So that's why you don't see a primvar behind them. In this case, you're going to see that there's a lot of attributes here that are primvar, but these are all attributes that are coming from our particle simulation. We want to go ahead and affect our display color. So to do that, we're going to go into our PopSim. we're going to drop in a USD print bar reader. Very good. And it's a vector, right? Because colors are vectors. So we're going to drop this here. And we're going to say display color, because that's the one that we want to bring in. And now I want to drop this into my, oops, come on now, base color. And I want to drop this into my emission color right there. So now let's see, what are we looking at? Am I bringing in my colors? Yes. Perfect. I am bringing in my colors. Now, if you notice, we have another problem. Our particles. Absolutely massive. Let's go ahead and fix that. To fix that, you'll see here that we have this attribute called widths. Widths is the equivalent of p-scale. And if you notice here, it's getting the same values as our p-scale and bringing them into each particle. Remember how we kept it between 0 and 1? This is all those attributes here. Now, for Solaris's point of view, this is way too big, as you can see here. So we're going to press 1 on our keyboard, and we're going to go ahead into our attribute adjust float node. And I'm sorry, we left it between 0.1 and 0.5. And we're going to adjust this. Once again, I already knew what values work best. So let me go ahead and put these in. So we're going to do here 0.0005 and 0.004, right? And just because we want to be special, let's kind of keep them all a little bit on the smaller side, right? Now we're going to press 2 on our keyboard again. Let's look at what we have. And they're back. Look, they're all small. Space G on the keyboard to bring us back to where we were. And now we're getting something nice. We're getting something cool. I don't like seeing the highlight on my viewport, so I'm just going to go ahead and turn that off. And another thing I want to do is I want to create a grid because I want to see my emission. So let's go ahead and, I'm sorry, I'm going to do a merge. Let's go back into our viewport here. We're going to do a grid. I'm going to bring this in here. I'm going to call this floor. And once again, copy parameter. This exists in our environment. Base relative reference, / Let's go ahead and get rid of this last / here. Cool. So now we have environment and we have our floor. Let's add a material library here. And inside of here, we could do a material builder. Call this floor. And let's lower down our color to, let's say, 0.25 and our roughness to 0.5. Why not, right? Let's adjust these later. Another thing that we could do to assign materials in Solaris is by clicking Assign to Geometry. And it's going to ask us what type of geometry. Well, if you notice here, once I visualize here my merge, this floor is a mesh. This is a mesh primitive. So I want it to go to my mesh, all mesh primitives. So it's getting applied here. Perfect. Now, I think this floor is way too small, so let's crank this up to 100. And just to keep ourselves organized, we're going to drop a null. And I like to change my nulls here so that they look a little bit different, so that way I can see them right off the bat. By the way, to change the shape of a node, you just have to press Z on your keyboard and drag whichever one you want. In this case, this is our environment. I'm going to go ahead and copy this, paste, drag this in here, and I want this to be my cam. We're going to drop in a camera, drag this in here, call this undercam. We'll leave it, let's change this to 300 focal length. And let's look through our camera. We're going to lock it so we can move it. Right? Let's do something. Let's get a nice little angle here. Something cool. Something like this. Yeah, why not? Something like that. Then we're going to click off on the lockbox. Let's add in here some lights. Put this in here. Let's say LGT for lights. We're going to do a dome light. And I want to use one of the ones that automatically come with Houdini under our HDRI. We're going to get Len Nong. I'm sorry if I'm saying that incorrectly. And I want to bring this intensity down really low because I want to have the light of my particles to basically do all the talking. So let's bring this down to 0.1. Yeah, why not? Let's do something like that. I also don't want to see my little light inside, so we're going to go ahead and just turn that off. And then from here, we're going to drop a render geometry settings. And why am I doing this? Well, because I'll tell you why. I'm going to drop in my points. And remember, our points have an emissive material. So I want those points to render as lights. To do that, we need to create a render geometry setting. We go down to light, treat as light source. We say yes. And it's going to give us more accurate lighting and more optimized workflows as well. Another thing I want to do here to kind of finish it all off is drop a karma node. Go in here. Now this is complaining because it's looking for a camera that doesn't exist. If we click on here, you see that there is no camera 1. That's because we have render camera. That's the one that we want. So it stops complaining. We want to see this at HDTV 1080. Change this to XPU. We want to leave it at 128. We can leave it at 128. I'm going to bring mine up to 256. And let's see what we're working with thus far. Oh, let's go to our render settings here. And we're not seeing anything because there is no emissions. Nice. Let's bring this to 2. There you go. So now we're getting something. We're getting something cool. We're getting some nice little shadows here, some nice little reflections. Let's go ahead and just play with these settings a little bit more. Could do maybe up to 2. So what's that give us? All right, yeah, that gives us something cool. Let's leave it at that. And another thing that we could do here, if we don't really like how this is looking, is we can create a color correct. And under this color correct, we can start playing around with this. Let's say we don't like it. Maybe it's too saturated. We bring it down. But in this case, I like the saturation, so we'll bring it back up. Let's say we want to increase our contrast. We'll do 2. But let's say it's too much. I want to bring it down. Maybe it's 0.5. Oops. We can bring it to 0.5. And look, we're getting some very interesting results. Let's leave this at 0.75. Yeah, why not? Let's leave it at that. Our gains is our highlights. So we can, let's say 5. And it's bringing up these hot spots here. We don't want that. Let's bring it down to 0.85. Why not? I want to bring this up a little bit higher. Let's leave that at 1. 1 is fine. We'll leave it at 1. Okay, cool. You can also hook this up into here. And you'll have the data being going into your base color as well. One final thing to go over is once you got everything going on your USD render ROP, you're going to go ahead and pick your specific frame range. We're going to leave it at 11096. And then we render to disk. Once we render to disk is we're going to start rendering. So I know that this was a long tutorial, but hopefully you guys understood how particle advection by velocities work. Hopefully you guys understood how to manipulate your particles velocities using Houdini volumes, and hopefully you guys learn a little bit more about rendering within Karma. This was my first tutorial, so I'm definitely learning as I go as well. Comment down below what you guys want to see a tutorial on next. Maybe you guys want to learn a little bit more about smoke simulations, or rather particles, or procedural modeling, or rendering, such as this. Rendering is always fun. But yeah, I'm going to go ahead and hit you guys with the standard. Don't forget to hit that like button, subscribe, and I'll see you all in the next video. Thanks.